Completing the square. So previously we solved quadratic equations that looked like ax squared plus bx plus c equals 0 by factoring and then using that using the zero product property, so that the two factors multiplied together equals 0. One or the other factor has to be equal to 0. But if the quadratic is not factorable, then we need a different strategy. So for example, if we have x squared equals, x squared plus 8x plus 6 equals 0, well, we go, okay, we'll look for factors of 6 that combine to 8. Well, 6 plus 1 is not going to work. Those add to 7. And 2 plus 3 doesn't work. Those add to 5. So it's not factorable. And if it's not factorable, it means we're going to need a different strategy to solve this type of equation. Completing the square is a technique for writing a quadratic like x squared plus bx plus c equals 0 as something like x minus h squared equals k, which we know we can solve now by using that square root property. So this is going to let us solve quadratic equations that can't be factored. So this means for that polynomial that we saw earlier, like x squared plus 8x plus 6 equals 0, this quadratic equation, we're going to be able to solve it. But to start with, we're going to look at some simpler examples and build our way up there. When we have a quadratic equation that can't be factored, our goal for completing the square is actually to manipulate the quadratic equation a little bit so that part of it can be factored as a perfect square trinomial. So I want to just do a quick recap of what a perfect square binomial, or x plus h squared, is the factored form of a perfect square trinomial. So let's take a look at what the perfect square trinomial looks like in unfactored form, in expanded form. So if we were to FOIL this out, first terms we'd get x squared. Outside we'd get xh, or I'll write it as hx, inside plus hx, and last plus h squared. So if I was to rewrite that, I'd have x squared plus 2hx plus h squared. And if we were to do that with the x minus h squared instead, we'd get something very similar. I'll leave this to you to expand it out if you want to do that, but you'd get something that's minus 2hx plus h squared if you had that minus in there. So basically what we need to do is we need to take our polynomial or our quadratic, and we need to manipulate it a little bit in order for it to be a perfect square. So for example, x squared plus 6x, what does it need in order to be a perfect square? Well, looking at the patterns above, if 6 is 2 times h, then we need to add half of 8, or half of 6 squared. So if 6 is equal to 2h, then h is equal to 3. So we need to add 3 squared, which is 9. If I add 9, then I have a perfect square trinomial. This can be factored as x plus 3 squared. For any quadratic to complete the square, we're going to find the coefficient in the x term. So here's an example. Let's say we have x squared plus 10x. We find the coefficient in the x term, that's 10, and we divide it in half. We get 5, and then we square it, and that's the number that we have to add to this quadratic equation, this incomplete perfect square trinomial in order to make it a perfect square trinomial. So if we were to do that, we'd then have x squared plus 10x plus 25, which is equal to x plus 5 squared. Now, in mathematics, we can't just add whatever we feel like it to an equation. So if you ever want to add a number into an expression or an equation, you have to balance that addition somehow. When we're solving equations, we add something to the left-hand side. We also have to add it to the right-hand side. For an expression, one way to do this is by adding a number and then subtracting it right away. Because if you add a and then subtract a, the net is 0. So it doesn't change what the expression is. It just changes how it looks. So we're going to complete the square for x squared plus 8x following that process we saw above. So first we find the number in the x term, 8. We divide it by 2, and we get 4. And then we square 4, and we get 16. 16 is the number that we want to add to this polynomial so that we create a perfect square trinomial in here. But if we want to add it, we also have to subtract it at the same time so that we're not actually changing mathematically the value of this expression. So that means we get x squared plus 8x plus 16 minus 16. And I'm putting the first three terms in brackets because x squared plus 8x plus 16 is a perfect square trinomial. We can write this as x plus 4 squared. And then of course we have this minus 16 left over. But this expression is equivalent to x squared plus 8x. And you can do that you can prove that by expanding it out again. And I'll leave that for yourself. Now this this skill is requiring you to be very comfortable with perfect square trinomials and factoring and expanding perfect squares. So if you're a little bit out of practice with this, I recommend you go back to the lessons on factoring and check out the lessons and skills for factoring perfect square trinomials. One last example. So x squared minus 12x, we want to complete the square. So we start by taking minus 12 because that's the term with the x, and we divide it by 2 to get negative 6. And then we square that number and we get 36. So to complete the square, minus 12x, we add 36 and then we take it away. So the equation is mathematically equivalent, except now we have this perfect square trinomial. So that would be x squared minus 12x plus 36. That's equivalent to x minus 6, and it's minus because we have this negative in front of the 12, in front of the x term. So it's x minus 6 squared minus 36. So that is the completed square for x squared minus 12x.